Hey everyone, welcome to episode 4 of the series on circles. In the third episode, we have discussed chord of contact and equation of chord bisected at a point and director circle. So we have discussed all these concepts in episode 4. In this episode, we are going to discuss intersection of two circles. So if you are not sure about these concepts or if you want to understand these concepts, go back to episode 3. The link to episode 3 is given in the description. Alright. So in this episode, we'll discuss this particular concept, intersection of two circles. And in episode 5, we will be solving some problems. To be specific, 3 problems based on the intersection of two circles. Alright. So let us move ahead. So intersection of two circles. So let us say there is a circle with center C1 and another circle with center C2. Then, so if this circle and this circle, if they do not touch each other, we can draw two common tangents to those two circles. And these common tangents are called as direct common tangents. Alright. So this is the first case. These common tangents are called direct common tangents. And also when the two circles, same case, when the two circles are not intersecting each other, we can draw two common tangents like this. And these two common tangents are called as transverse common tangents. Alright. So this is the first case that we are going to analyze. Understood? So let us say the radius of first circle is R1. So this is R1. And the radius of second circle is R2. So if that is R1, so we can draw a line joining C1 and C2, which are the centers. So this particular length is R1 and this particular length is R2. So if you try to calculate the distance between C1 and C2, the centers of two circles, so this is greater than R1 plus R2. If this condition holds good, then you can say the two circles are not intersecting each other. And in that case, you have two direct common tangents and two transverse common tangents. Now, let us proceed to the second case. In this case, the two circles touch each other at an external point, and this is that particular external point. In this case, you can draw two common tangents which are direct common tangents, and there will be one transverse common tangent. Alright. So this is one transverse common tangent. So what is a direct common tangent? So if the two circles lie on the same side of the tangent, then such a tangent is called as direct common tangent. So if you consider this, both the circles lie on this side of the tangent. So this is a direct common tangent. Whereas in case of transverse common tangent, one circle lies above the tangent and one circle lies below the tangent. Alright. So if the circles are touching externally, we'll have two direct common tangents and one transverse common tangent. And in this case, if R1 is the radius of this particular circle and R2 is the radius of this particular circle, then the distance between the centers is equals to R1 plus R2. Alright. Now let us move to the third case. Alright. So the third case is where your circles are intersecting each other at two different points. This is one point and this is one point of intersection. In this case, we can draw two direct common tangents and we cannot draw any transverse common tangents. In this case, let us say this particular distance is x and this particular white color distance is y and this particular red color distance is z. Now your R1 is equals to x plus y and R2, radius of second circle, is simply y plus z. So if you find out x r1 plus r2, that is x plus y plus z plus y. But x plus y plus z is simply the distance between the centers c1, c2. So your r1 plus r2 is greater than c1, c2, the distance between the centers. If you find out r1 minus r2, that is simply x plus y minus z. So what I'll do is I'll add z and I'll subtract z. So then you will get this. So this is simply c1 c2 minus y minus 2z. So your r1 minus r2 is lesser than the distance between the centers. So r1 minus r2 is less than distance between the centers. So from here we got c1 c2 less than r1 plus r2, and from here we got this. So combining those two, you'll get this particular thing. So your r1 minus r2 less than the distance between the centers less than r1 plus r2 for case 3. This is for case 3. So if this happens, the two circles intersect each other at two different points. So now let us move to case 4. Alright, case 4, we have one circle here and the other circle touches the bigger circle internally at a point. So in this case, we have one direct common tangent and there will not be any transverse common tangents. Alright, now if you consider this distance is r2 and this total distance is r1. So distance between the centers c1 c2 is simply r1 minus r2. If the distance between the centers is just the difference of the radii, then the circles touch each other internally. Alright, this is case 4. So let us proceed to case 5. In case 5, one circle lies inside the other circle. In this case, if you consider the radius of c1 as r1, so this will be r1 and this part, this white part will be r2. In this case, the distance between the centers is lesser than r1 minus r2. Here the distance between the centers is exactly r1 minus r2. So now the centers are getting closer to each other. So therefore the distance between them will be lesser than r1 minus r2. So we have 5 conditions. If this happens, the circles doesn't intersect each other. If this happens, the circles intersect each other externally at a point. If this happens, the circles intersect each other at 2 different points. If this condition happens, they intersect each other internally at a point. And if this happens each other, one circle lies inside the other circle. So this is the concept of intersection of circles. Let us move ahead and check this case. So let us say your circles are not intersecting each other. Now you have a direct common tangent T1. Now I want you guys to find out the length of this direct common tangent. So this particular length. Alright, how do you do that? So let us try to derive this. So let us say the radius of the bigger circle is r1. Since radius is perpendicular to tangent, this angle is 90 degrees. Similarly, let's say the radius of smaller circle is r2, and since radius is perpendicular to tangent, this is 90 degrees. Now let us join the centers C1, C2. Alright, now let's draw a line parallel to the tangent, something like this. So this is a line parallel to tangent. Now this length is equals to r2. So therefore this length is r1 minus r2. Understood? That length is r1 minus r2. So we have to find out this particular distance. This is the length of the direct common tangent. Let us say this is D. And now this is the distance between the centers. If you have two circle equations given, you can easily find this distance. So now let us apply Pythagoras theorem in this triangle. So that will give us D square plus R1 minus R2 whole square is the distance between the centers whole square. So this you can find out from the equations of the two circles given. Alright. Now similarly, let us proceed. And let's say now you have two circles and you have to find out the length of the transverse common tangent. So this length, you have to find out this length. So let us say this length is L. Alright. Now let's say this radius is R1. So this is R1 and this angle is 90 degrees. And let's say this radius is R2 and this angle is 90 degrees. So now let us join the centers. This is C1, this is C2. Alright. So now what we can do is we'll try to draw a line parallel to this tangent. So in the previous case also we drew a line parallel to the tangent. So this particular line. So we will use the same concept here as well. Alright. So we'll draw a line parallel to the tangent. This one. So now this particular length will be equal to this length. So this is R2. Now you have a right angle triangle here. So this is your right angle triangle. If you apply Pythagoras theorem here, you will get R1. You will get R1 plus R2 whole square plus this is simply the length of your transverse common tangent. We are denoting it with L is equals to this thing. This is the distance between the centers. Let us say that is D. So D square. So your length of transverse common tangent is simply square root of D square minus R1 plus R2 whole square. Here your length of direct common tangent is, let us say, let's denote that by D and let's denote this by D. Denote this by L, the length of direct common tangent, and the distance between the centers is D, let's say. So in that case, it will be simply D square minus R1 minus R2 whole square. So this is the length of your direct common tangent and this is the length of your transverse common tangent. So that is all for this video. So if you like the content that I'm making, share it with your friends, subscribe the channel for more such content, and do not forget to like the videos. If you have any queries on whatever I've explained in this episode, you can always reach out to me in the comment section. Even if you have any generic queries, you can write them down in the comment sections. I have the Telegram link attached in the description. Do check it out, join the channel, and also check out the other videos in this playlist on circles. I'll meet you in the next video, and in the next video, we'll be solving 3 good problems from the concept of intersection of circles.